Okay, 7-2. This is where the fun begins. So, we are solving exponential equations and inequalities. Actually, we're just going to do equations. And I'm going to be giving you guys something called a Powers Pocket Guide. And that should sound somewhat familiar because I passed those out when we did this section your freshman year. But I'll give you a new one. So basically, here's what I know. If I have 2 and I want to make it 4 using exponents, what power do I need to use to make it become 4? 2 to the what power equals 4? And I know that that would be squared, right? I know that x has to equal 2. Okay. How I can rewrite that is saying that 2 to the x, or 2 squared, is what gives me that 4. Or another way I can write that would be 2 to the x equals 2 squared, meaning that the x has to equal 2. Okay, it's kind of funky to explain to get started, but once we do some examples, it'll make some sense, I hope. Essentially, the question you need to ask yourself this entire time is, how can I get the bases to be the same? Meaning the number that's on bottom. So when I look at A, I generally start here. I say, okay, my bases are 2 and 8. The smaller base is 2. Make the big base become the little base. So how do I make 8 become 2? And I know I can do that by making it 2 cubed, because 2 cubed is 8. So you leave that as 2 to the x equals 2 cubed. Now here's the catch. There was this 3 here at the beginning, so you do need to keep that exponent there, like so. So 2 cubed. Now I do remember that when you have a power of a power, that would actually be multiplication. So really, I could just write this as 2 cubed times 3. 3 times 3. When your bases are the same, you can kind of think of it as canceling, which is just going to give me x equals 3 times 3. And double check that, or simplify that, x equals 9. You can double check this. Plug it into your calculator, okay? 2, where do I want to write this? Let's go ahead and box that answer for starters. 2 to the 9th. Plug that in your calculator. What do you get? I'm plugging it in right now. Hang on. I get 512. Plug in 8 cubed. What do you get? 512. Okay, it does equal itself. So that's how you can kind of double check that you got the correct answer. Now, of course, we're going to make things a little more interesting, like with 1a, how it has that 2n minus 1. So first things first, I'm going to probably change that 64 base. I know that 4 cubed gives me that 64. So now my bases are the same. And do you notice how I bring down the entire 2n minus 1? Now you just have a 2-step equation. Oh, why did I write a 2? N equals 2. Now let's talk about number 13 here. Number 13 is going to do something really interesting. Because 9, there is not a power, 9 to whatever power, that will give me 27. But I noticed in my Powers Pocket Guide that 3 squared is that 9. Notice how I just write the entire parentheses there? And 3 cubed is 27. So you can actually change both bases to get them to be the same. So now I would have 6c plus 2, do you see what I did there? Equals 9c minus 3. Okay, you can solve that from there. 4a and 4b, those are going to do some funky things. Do you notice how it's on the bottom of the fraction here? First things first, I really just want you to look at this like it's just like that 243, pretend it was on top. Just ignore it for a minute. And so 3 to what power is going to give me that 343? And the answer is 3 to the 5th. Now I can't just write 3 to the 5th. Okay, you need to make it 1 over 3 to the 5th. 1 over. Now, you kind of have bases the same, with the exception that this 3 to the 5th on the left or on the right here is on the bottom. However, do you remember the rule that says I can move that to the top if I change the positive negative of the exponent? Check this out. 3 to the negative 5th. Now that my bases are the same, they can cancel. The one base wasn't underneath a fraction anymore, so that's good. Now you can solve from there just like normal. Okay? Same rules apply on those inequalities, by the way. Don't forget that if you multiply or divide by a negative, you need to switch the sign. Okay, I want to give you one more example that I'm just going to kind of make up over here. La-di-da-di-da, make up land. And let's make it 4 equals 16 to the x. So this one's a little different, only because of the lack of exponent on the 4. Because when I recognize that 16 is just 4 squared, and I'm going to bring that x down with it, when the bases cancel, what's over here? Well, the answer is, what exponent is there? Remember, if it's not written, we can always know that there's an exponent of 1 on everything, so that 1 is what I would bring down. So that now, when I divide by 2, x equals 1/2.